In this question, we want to find the derivative of f of x equals e to the x plus 1 over the square root of x. So in this example, I'm noticing that I have a fraction, and with the fraction, both the numerator and denominator have the variable x in it, and because of that, we're going to use the quotient rule to find the derivative. So to find the derivative, we're going to follow that quotient rule, and the quotient rule says that we're going to do the denominator, which I'll rewrite as x to the 1/2, times the derivative of the numerator minus the numerator, so this should be derivative of the numerator, minus the numerator times the derivative of the denominator, all over the denominator squared. So this is applying the quotient rule because we have a quotient in our original function. So I'll start to do the derivative calculations. The derivative of e to the x is e to the x. The derivative of 1 is 0. And the derivative of x to the 1/2 power, I'll use the power rule, so I'll bring that power down and take 1 away from the power, so that gives me negative 1/2. And in my denominator, x to the 1/2 power squared will be x to the first power. When you multiply those exponents together, you would get 2 over 2, which reduces down to 1. So then we want to do a little bit of algebra cleanup on this example, and we would notice that I have a fraction here, 1/2. So in order to make my algebra cleanup a little easier, I want to have that same denominator over here. So I'm going to put 2 over 2 so I can have the same fraction and factor out that denominator. This is going to allow me to get rid of the fractions in the numerator. And then I also notice that I have a common factor of x, and I'm going to take the lowest power on that x. So when I factor this out, this 1/2 will factor out. It's factored out right there. I'm going to factor out the x, but I'm going to have a new power on that x, and it's going to be x to the 1/2 minus negative 1/2. And the way that I got that is by doing this power minus this power. I'll still have that e to the x there. And I'm still going to have e to the x plus 1 in the second term. The 1/2 will factor out, and this fraction, or this x to the negative 1/2 power, will also factor out. And this is still over our denominator. We've got 1/2 x to the negative 1/2. And I'll simplify this right here. 1/2 minus negative 1/2 becomes 1/2 plus 1/2, which is 1. So you have x to the first power there. And I've got minus e to the x minus 1. If I distribute that negative over x, we can do a little bit more algebra to simplify this. I can bring this 2 to the denominator, and because this has a negative exponent, I can bring that whole factor to the denominator as well. So left in the numerator I have x e to the x minus e to the x minus 1. And in the denominator I have 2 x to the 1/2 times x. And you can combine these two x's together. You're multiplying expressions with the same base, so you can add the exponents together. So that becomes x to the 3 over 2. That's a 1 plus a half is 3 over 2. And if you want to go even further, you can rewrite this as the square root of x cubed. On this example, we want to find the limit as x approaches 0 of sine x times cosine x over x. This is another example when we try direct substitution, we're going to get 0 over 0. So when we try direct substitution here, sine of 0 is 0, cosine of 0 is 1, we get 0 times 1 over 0, which is 0 over 0. But we can recognize that we have our special limit. Our special limit is the limit as x approaches 0 of sine x over x, and that's equal to 1. So we're going to try to take advantage of that to rewrite. We're going to apply the limit to this factor of sine x over x, and then also apply the limit as x approaches 0 of cosine x. So we know the first limit is 1 because we've memorized that special limit. And the limit of the second one we'll use direct substitution to get cosine of 0. And cosine of 0 on the unit circle, an angle of 0 is here. That point is 1, 0. And cosine is the x-coordinate on the unit circle, which is 1. So that's cosine of 0 is 1. We get 1 times 1, which is 1 for that limit. So this example says, limit as x approaches 4 from below of absolute value of x minus 4 over x minus 4. So if we were going to solve this with direct substitution, we would get absolute value of 4 minus 4 over 4 minus 4. We get absolute value of 0 over 0. And that is 0 over 0, an indeterminate form. But I recognize this expression here as 1 because it has the numerator and denominator being the same factor. That usually simplifies to being 1. Like if we had 5 over 5, that reduces to 1. But the absolute value kind of throws a little bit of a curveball in there, in that this expression sometimes will equal a positive 1 and sometimes it will equal a negative 1. So let me just kind of give you an example. If I let x be equal to 5, this expression would be absolute value of 5 minus 4 over 5 minus 4, and that's absolute value of 1 over 1, which is 1 over 1, and that's 1. But if I let x say equals 0, this would be 0 minus absolute value of 0 minus 4 over 0 minus 4, and absolute value of negative 4 is positive 4. In the denominator we have negative 4, and that answer comes out to be negative 1. So this expression that we've got is either going to equal positive 1 or negative 1 based on what x value we plugged in. If we were to think about the graph of this, what it would look like if we go to where x equals 4, it would be a horizontal line at negative 1 and a horizontal line at positive 1. And if we think about the limit, we're finding the limit from below. So we're going to be tracing this path here, and that limit from below is approaching a y value of -1. So this limit is -1. We want to find the derivative in this example, and our function is y equals sine squared x minus cosine squared x. The first thing I want to do is rewrite my trig function so that it's sine of x squared. Now, the reason why I do this is because it helps me recognize how to apply the chain rule properly. With the chain rule, you have an inside function and an outside function. We have the squared as our outside function, and we have the sine, and over here the cosine as our inside function. When it's written in this shorthand, it's hard to recognize what's on the inside and what's on the outside. So I'm going to apply the chain rule to find this derivative, and I'm using the power as my outside function. So I need to follow the power rule. So to follow the power rule, I'll bring the power down and take one away from the power. And then the chain rule says that I need to leave the inside the same and chain it by multiplying by the derivative of the inside. I'm going to do the same thing on the second expression here. I've got the power being the outside function. I'll bring the power down, take one away from the power, leave the inside alone, and chain it by multiplying by the derivative of the inside. So to simplify this, I've got sine x to the first power, which is sine x. The derivative of sine x is cosine x. Then I have cosine to the first power, which is just cosine. The derivative of cosine is negative sine x. Then I'll simplify. I have 2 sine x cosine x. Negative times negative is a positive, and I have 2 cosine x sine x. Now these two terms are like terms, so I'll be able to combine them together to give me 4 sine x cosine x. And then if you want to get a little bit fancy, there is a angle identity. It's called the double angle identity. And the double angle identity for sine says sine of 2x is 2 sine x cosine x. And since I have sine x cosine x here, what I can do is I can take and break up this 4 into 2 times 2. And I can take this 2 sine x cosine x and make that 2, not 2. Make it sine of 2x and bring that 2 down. So I found the derivative of sine squared x minus cosine squared x to be 2 sine of 2x. On this question, we're given that f of x is this piecewise defined function where whenever x is less than or equal to 2, our function is defined by 3x minus 5. And whenever x is greater than 2, our function is defined by 0.5x squared. And we want to find this one-sided limit here. And this limit is the limit as x approaches 2 with a plus, so that's from above, of f of x. So 2 from above, what I'm going to do is go over here to my piecewise defined function. And because we have the 2 plus, which means more than 2, x is greater than 2 means more than 2. So I'll use this second equation to calculate my limit. So I'm going to use direct substitution into that second equation. And that is 0.5 times 2 squared. 2 squared is 4, and half of 4 is 2. So we found that one-sided limit.